And what that does for us is a couple of things. Now, internally, it's great because our contribution margins are higher. And if you think about contribution margin, it's revenue minus variable cost. Our variable cost is labor, and it's the direct materials associated with depositing on that glass. We don't have the raw material cost of the glass itself. So that helps us have a high contribution margin, helps us pay off these factories in less than a year. So very CapEx efficient from that standpoint. And at the same time, it's priced such that when our customers use the technology, their cost per watt is flat. So we've taken the economic disincentive out of the equation. We don't have to have the conversation about, well, gee, what's the value of what you're delivering versus what I can sell in the market? We just say, you know what, you were paying 35, your module cost was 35 cents a watt, just as an example. It's still going to be 35 cents a watt. And one would ask, well, gee, how is that? Well, yeah, we charge for our glass, our coating is transformation. But the power goes up. So we're able to charge just for about as much as that power goes up. And so, we sell for roughly 10 cents a watt. And we still make great money. And the customer now has the customer,
just so I'm clear.
Oh, Scott, I see. Because the panel is 35 cents a watt, but its wattage went up. So I see where
right, but the customer takes delivery of a piece of glass with your specialty material on it. They then add the bus bar connectors, frame, etc. Right. Okay, and then they sell the finished goods.
And so basically think about using it just like you would use any other solar glass. There's only two real differences that we see that'll be needed. One is an extra step in the bus bar connection station. So with the busing station, we typically has been manual for a very long time. It may have automated in some places, but there's really a couple of pieces of charge collection tape going from the silicon cell array. So if you think about module manufacturing the glass, then you've got the foil, then you have the strings that are laid out. All we need now is to connect the glass to that bus bar array that we have to the bus bar associated with those silicon cells. And then you have the electrical connection. So we put the electrical connection on our side. So we have a place for that tape to go, or whatever material our customer decides to use. It's up to them. But now it just goes through a standard process. And the lamination is a little lower temperature than you would do normally, but there's plenty of lamination encapsulants that are already being adopted in the industry that we can leverage that provide the lifetime that's needed for a PV module, and then can still be in production. Now, what we have is what's called a 4-terminal architecture, and that's a little special. A lot of guys are thinking about 4-terminal, but our approach to 4-terminal is bring 4-terminal to everybody. Let's not create our own modules, the 4-terminal. The idea there is that if you look at some technologies, they take the silicon cell, and they say, well, let me just go and put the perovskite on top of that. And you can get higher efficiencies, absolutely. The problem is degradation. And it's about a point difference in absolute efficiency by doing it in an integrated monolithic tandem like that is versus what we do. But the downside is that perovskites and silicon, they degrade differently. Perovskites today are a little faster degradation. They're a bit faster degradation than crystalline silicon. Crystalline silicon still degrades. That's why the warranty is 8%, 5 years or so. But because of that, if they're integrated on top of each other, if the perovskite degrades faster, you start having current mismatch. And that circuit's in series. It's like putting a resistor in there, and that resistor gets bigger over time. The current drops. If you connect them in parallel, like what we do, well, you just add the currents. You just have to match the voltage, and the voltage matching is a heck of a lot easier. So it's a parallel circuit, match voltage, add current.
Oh, wait a minute. So your glass is a separate layer than the silicon that will exist underneath. So they're basically two generators at that point.
Exactly, and they're separated by lamination foil.
Okay, so there's insulation between them, and you're getting irradiance.
Yeah, let me go grab a. I don't know if your listeners can see this.
They will in a second.
Here's an example.
There you go. Okay.
Here's an example. Right, you can see the crystalline silicon cells here.
Yeah.
And then this is the perovskite here. Now my team gives me only the crappy ones because they know I get my fingers all over it.
So you have two isolated generators, and you're just combining voltage on. Okay, that makes sense. And then you're reducing the degradation of the perovskite because you're isolating them and you're not having them lay on top of each other.
And this can degrade faster. And our view is that we can commercialize sooner by having this setup than if you were to go and integrate them together, because we don't have to solve as many physics problems as the folks that are doing monolithic tandem do. So the perovskite can degrade a little faster, But the way that our architecture works is at the end of life with our first product, Caelux 1 in 24, it'll still have more power at the end of 25 years than if it was just silicon alone.
Because they're isolated. And one can degrade and it doesn't affect the silicon layer.
Just add the current. Just keep adding the current.
I got
it. Now,
it.
because it's dark, now if you see this, it is dark, right? So the perovskite is absorbing high energy light. And what the bottom cell array sees is about 43% of what it would see if it was on its own. So the way to kind of do the math is you take the efficiency per square meter of perovskite, and you add that to 0.43 times the efficiency of the silicon module, and that's what your total module output would be.
But still, net effect is 20% or 10. What did you say? 20 to 30% additional power out of the same frame.
Exactly. Exactly. So you have the same real estate, and because we're not coming out with our own module, we can have these conversations with everybody and say, hey, how would you like to go sell your module for more money? Your cost per watt's going to be flat. And by the way, your developer partner is going to see an economic benefit. They can either put 50 megawatts in a much smaller size, land size, or they can put in more. They can put in, 1.3x 68 megawatts into that same size. And so that's really kind of the idea.
And can you do this with sort of anyone? You could team with SunPower, for example, on the high end side. Yep. You could team with Longi. You could team with sort of anyone, because you're just you're switching out their glass basically.
Yeah, and here's the scary thing. I think this is what gets people on the high end a little worried. Let's say you've got a pretty low wind panel today, 160 watts. Okay, so we can do the math here. Right? So 160 watts, that's going to get you put a perovskite on. So let's just do the math. So 160 watts per square meter, 16%, right? Times 0.43. So 160 or 0.43 times. So that's 68 watts. Then you throw our stuff on, which Caelux 1 will be 175 watts per square meter. So you've taken your 16% module, and now it's a 24.3% module.
I mean, so you're really, so is the focus for you not the high end performers like the HIT modules from Panasonic or others? It's the low end, Jinko stuff, or who's really attracted to this?
It's everybody. It can be anybody, but our investment came from Reliance Industries, as you know, and Reliance acquired REC, and REC is a leader in heterojunction.
Yeah,
so,
the high end stuff.
Is, hey,
yeah.
Yeah, absolutely. So go take our stuff and then put it onto that module. So, right, if you're starting, let's say by that point, a 24% module, 0.43 times, or, 243, sorry. I should be able to do this stuff in my head, but I have a hard time like multiplying 240 times.
I think it's plus 50. Don't worry about
it. Yeah. So
then the output here is, because of the addition of the new perovskite glass, you now have a higher power module within the same form factor. So situations where real estate is valuable, that's going to be a great benefit. And
yeah,
even in situations where real estate is not that valuable, it's going to save on balance of system costs, because you're going to need less panels, less wire, less racking, and all of that.
Or you have the optionality to build out.
Yeah. Or what?
Scott? That's right. No, to John's point, he's absolutely right. And so the difference when we looked at it from a project.
No, Scott, say it again, because I don't think Karen didn't hear what I said, because we spoke at the same time. So say it again.
So you have the optionality to really do what you want. And the way the economics played out, so we consulted with a project developer, and we brought them in and said, look, this is what we're thinking about. What's the best way to think about the value add given our price points and what we're trying to do? And he did the math. And what he showed is that, look, if you decide that you want to have a smaller footprint site, you would have a after-tax IRR that would be 170 basis points higher using our technology. So 1.7% higher after-tax IRR, which is big considering most of these are around 7% today. Or, if you decide to go with a bigger site and just monetize more, or the same size site and just monetize more kilowatt hours, then you have about 130 basis points improvement. Either way, you're well north of 1% improvement in after-tax IRR for a US project. And so
That's a big delta.
Yeah.
I mean, I worked on opportunity zone capital deployment, if you remember when that happened under the Trump administration. That was 150 basis points of IRR improvement, and it became very popular with equity positions. Yeah. So this kind of numbers from a qualified developer must make it very, very attractive to.
It does.
Yeah.
Yeah. And look, our first customer is going to be REC, right? And we're public about that. That was in our press release, and they want to capitalize on this efficiency because it does translate to significant value for their downstream partners. What the important part for us too, and John, you have a good appreciation for this, is that if you're a small, and I think you do too, because working with TV manufacturer doesn't have the same cachet from a warranty standpoint as working with a Trina or working with a big player that actually has the balance sheet back the warranty. In our case, it's the RECs of the world that will be the face of the customer that'll have the warranty. Now they're going to beat us up to make sure that we don't compromise their warranty. And we're looking forward to that. We do coordinate very closely on durability topics to make sure that we can ensure that we're not going to undermine their brand and their value. But they're going to be the face, and it'll be their warranty. So as a developer, you go, oh, well, it's this REC with Caelux inside, module, or it's a JA plus Caelux, or it's a Trina plus Caelux. The list can go on, but that's the idea. And our ambition is to really, change the name of the company to a verb. And one could argue, is that really great? But the reality is I want that. I would love every project developer in the world in 2024 to say, hey, the returns are this. What if I Caelux the project? What do I get? And if it pencils out better, we hope that drives more revenue, more solar. And, part of the ambition for the company is that, and John, you know these numbers better than I do, but, we want to have 40% of electricity in the US coming from solar by 2030, right? 2035. 2050, half the world should be powered by solar. But that's really going to require that we drive the module cost down significantly. And our technology is the gateway to achieving those goals. And the world needs more powerful, lower cost modules. And that's where we think perovskites really fit. And, if I think about the mission and vision for our company, we try to keep it super simple. The mission of the company is to launch this Caelux One product because we do think it's going to be transformational for the industry. The second thing, when we think about our vision, it's ubiquitous solar. We want to be part of that solution to deliver 50% of the world's electricity generation coming from solar. That's how we think about it.